Hello everybody, welcome to Statistics and Theory. In this video I'm going to demonstrate how to do a latent class cluster analysis using Jamovi, which is a free software package which you can download from this website. Uh, the different versions of Jamovi are available for different operating systems like Windows, Mac, Linux, and Chrome, so it's very versatile. I will leave this link in the comments section just under this video. Before we start, I would like to recommend that you go to my channel and perhaps watch this video before watching this current one, two-step clustering using SPSS. I mean, it will just provide you with some sort of introduction to what clustering is. In addition, I would like to suggest that you take a look at this paper which I published a couple of years ago, in which I use latent class analysis or latent class cluster analysis. So in the current analysis, I'm going to use a data set which is from a project which was led by Dr. Melvin Chan. This is his website, his webpage. So let's get started with Jamovi. After you download Jamovi, you need to install SnowRMM. If you have not installed it, please go to Modules, go to Jamovi Library, and under Available, find SnowRMM. Since I've already installed it, I can find it under RMM, under installed. So this is SnowRMM Rush Mixture Model for Jamovi. Inside this module, you can find separate types of analysis, such as latent class cluster analysis or latent class analysis, Rush model, etc. And here is how it looks like. As you see, right at the bottom, we have got latent class analysis. As for the data, I'm going to use a data which is available in SPSS. So I'm going to click on Import on this, Open, and this PC, Browse, and I'm going to open Factor Analysis. So the data that I'm going to use is not going to be used for factor analysis, by the way. It's just the title for the data set. I've got around 9 items, well, exactly 9 items I should say, and they are coming from a survey which was administered to a large number of people, which is around 1428, yes, 1428 people. There is some missing data, I should say, and the Likert scale that has been used in this survey ranges from 1 to 5, and basically 1 means strongly disagree and 5 means strongly agree, and there's a neutral point right in between, and that's category 3. Okay, so I would like to start the analysis. I go to SnowRMM latent class analysis, and this window appears. Now, what we need to look into and take into account is that the latent class cluster analysis only in Jamovi only works with nominal data and ordinal data. So you need to make sure that your data is either ordinal or nominal. In this analysis, mine is ordinal. If you're not sure whether it's ordinal or nominal, please toggle back to data and click on the header, double click. In this section, you can determine and specify the type of the variable. Here, as you see, measure type is ordinal. You can change it to nominal or continuous. If it's continuous, it should be changed into ordinal or nominal. I mean, sometimes the data is actually really continuous, so I'm afraid it cannot be used for this analysis. So I'm going back to analysis and latent class cluster analysis or latent class analysis. So I will move all these 9 items to the variable panel there. As soon as I do this, the fit statistics for this model is estimated. And what does that mean exactly? So basically, under this section, analysis, we can determine the number of classes 2 is, I suppose, is the smallest one that could go in. Let's just see if we can get a one class model as well. No, we can't. So the smallest one will be 2. Okay. And in addition to this 2-class model, we can get a latent class analysis plot, which looks like this. Now let's wait for it so it will be updated. Okay. I don't know how useful you'll find this plot, but the population share is pretty useful here. This means that in class 1, that's in group 1, we have 42.1% of our sample, and in the second sample, or in the second class, we have 57.9. So class 2 comprises a larger number of people compared with class 1. But I should also add that there is a good or even distribution of the two samples. In other words, neither of these two samples is extremely too big. So that's something good. That's more or less everything we can get from the latent class analysis. But we can also, I highly recommend that you do this, save the class memberships because they're extremely useful. And as you see, as soon as we click class memberships, this variable will appear here immediately. I'll show you what this is. So before I move to memberships, I should quickly walk you through the model fit statistics. There are two important statistics here for us to look into and take into account. So one of the statistics is AIC and the other one is BIC. In some literature, you might also, find entropy statistics to be useful, and also the chi-square value as well. So for AIC, let me go back to my own paper and read it from my paper, AIC, which stands for Akeke Information Criterion. It is basically a measure of relative fit or quality of the model to the data, which considers model parsimony, and that's the number of parameters. AIC is estimated based on log likelihood squared, that's represented by this symbol, and LLL. So I think in this analysis, what has been used is probably log likelihood. I'm not pretty sure because I wasn't able to find that sort of information on the website of Jamovi. But anyway, in either case, the AIC should be lower. So you need to compare a 2-cluster model, then a 3-cluster model, and so on and so forth to figure out which one of them has a lower AIC, and that will indicate that it has a better fit to the data. We also have a BIC statistic in the output, which is used to compare the fit of different models with lower indices indicating better fit. So actually that's more or less everything we need to know about these statistics, these two. Entropy in the same way should be smaller. The smaller the better. Now I would like to right click and copy this and then perhaps save it. So I have saved the statistics into this Excel sheet. I'm going to go back to the results and run a 3-class cluster analysis and see the results will be updated in this way. And also right click and copy the fit statistics and paste it right under, this is pretty small, maybe this way, okay, right under this 2-class solution. Now the next step will be to compare the fit statistics, especially these two, across the two models. Of course, what I would like to do is to actually add another model, maybe a 4-class model, since my data set is not too small. So I think it would still be meaningful to include a 4-class model in my analysis. So right click, copy, and let's just save it here. Okay, so let's look at these model fit statistics, these columns here. Well, like I said, the smaller these statistics, the better. Just by eyeballing these statistics, I can immediately see that the AIC here stands out because it's smaller. So I'm going to highlight this as the first piece of evidence that a 4-class model is a better one. Next is the BIC, and as you see, as we go down from in this way, from class 2 to class 3 and 4, the BIC continues to decrease. And here we have the smallest BIC. So this indicates that a 4-class model is actually perhaps has got the best fit. And even with the entropy variable, you can see that the amount has decreased as well. But I'm going to just focus on these two, and if I want to write a paper, I'll probably just stick with these two statistics because that's what commonly reported in latent class cluster analysis. So this is step one. Step two is that I also need to take into account the population share. That's the proportion of the data or the number of people who go into different clusters. So about 39.6, roughly 40% of my sample has been associated with class 1. About 80.3% has been associated with class 2. 50.3% goes to class 3, and class 4 comprises of 26.8% of the sample. Now, who are these people exactly? Well, in these graphs, or even in this part of the output, we cannot find that. So since we have already specified class membership here, Jamovi has already outputted that class membership, and it's a very useful piece of information. We go to data, and under class membership, you see we have got one class membership for each person. So for person 1 belongs to class 1, whereas person 2 belongs to class 4, and person 3 to class 3, and so on and so forth. Now, can we use this information to do some sort of post hoc analysis? Of course, and I highly recommend that you do so. But since I'm going to double click on the header of this, I'm afraid the type of this membership variable cannot be changed. I haven't been able to figure out a way to do so far. As you see, it's fixed. But what I need to do at this point is to create a nominal variable, because these memberships are actually nominal. So I want to just copy all the data in this column like this, and create another column beside it. Oh, no, it wasn't copied, so I'm going to do it again. So by copying and pasting the data into a different column, what I'm actually doing is to create a new variable, and that's a very important step. Okay, so copy and paste. Yeah, this makes sense. Now the variable has automatically been called K. I double click on that and change it into member, and it's a nominal variable. That's what I really need. Okay, good. So let's do some follow-up analysis. I'm going to toggle back to analyses, and I'll use exploration and get some descriptive statistics for these variables and the membership variable. As you see in the corner, for the membership, we only can move nominal variables. So if I click on membership, the original variable which was created in latent class analysis, it will not move, you see. But so that's why I created the member variable, which actually is basically the same as membership. So I move it to member, and now for each of the items I have statistics of each item across the 4 classes. For example, for item 1, for class 1, the mean score, let's say the mean score of people in class 1 is 4.59 out of 5, whereas the mean score for class 2 is 3.58. This is just for class 1. Then class 2 and class 3 and class 4. What you can do is basically to really quickly move everything to an Excel sheet. So let's do that and create some very useful statistics, useful graphics. Let me stop the video for a while and create one for you, then I'll get back to you soon. Okay, so I cleaned that part of the data that was not going to be used in creating the graphs. Uh, so I'm going to only use the mean statistics of the items across the four classes. How do you do this? Well, this is a very useful way of doing it, in my opinion. You go to Insert, and for example, we can either choose this type of graph, which is Insert Line or Area Chart, or we can choose this option here, which is a scatter plot. So I'm going to choose this for the time being. I will choose this type of scatter plots with straight lines and markers. And as you see, this is how it looks like. If you're interested to change the colors, you can always do that through this menu. For example, this one seems to be more interesting. You can put a title there. If you're not interested to include a title, you can just remove the title. And here is how it looks like. So we've got series 1, or that's class 1, class 2, 3, and 4. This is how the difficulty or the mean values of the items across the four clusters change across the items. Now I go back to Jamovi and I continue looking at the statistics here. The other thing that you could do with the membership and the items is to look into, for example, the skewness, kurtosis, or anything else that might be important and interesting to you. But what I would like to add here is the plots. The box plots, in my view, are pretty useful in this case. So I'm going to choose box plot, violin, data, and mean. All of these statistics, all of these options. So the numbers and statistics will be converted into this nice graph. For item 1, this is how the data is distributed across the four classes that we generated in our latent class cluster analysis. In the same way, this is for item 2 and item 3. For example, the mean for, let's just look at something that's more clear. The mean for item 4 in class 1 is here, whereas it goes down to this number, which is around 3 something, and slightly it slightly changes as you move from cluster 2 to cluster 3. I think the differences might be quite small, but there is definitely a significant dip from cluster 3 to cluster 4 in the mean of item 4. Now we can do some post-hoc analysis. For example, we can do an ANOVA test, maybe a one-way ANOVA, to see if there is any significant difference across those four groups. So my dependent variables are those items. So I choose all and move it to the dependent variable. And my grouping variable is member. So you can wait for the ANOVA test. This is the Welsh test. We can also get the Fisher's test, which assumes the equality of variances. Of course, you need to look into the homogeneity and normality test as well if you're interested to, check all the assumptions of ANOVA. That's something that I have discussed in another video. So what I just want to say in this video is, all of these variables, as you can see, are they have statistically significant differences across the four groups. So now you can do a post-hoc analysis to see where those differences are by doing some pairwise comparisons. Actually, you can watch my previous videos to to see how that kind of analysis can be done. So I would like to go back to the latent class cluster analysis and just wrap it up by saying that latent class cluster analysis is a very useful technique in which you can use qualitative, categorical, and nominal data. Actually, in Jamovi, unfortunately, so far we cannot use continuous data, but I think in the future they may add it to it. It's very useful in the sense that you can combine nominal and categorical data in one analysis. And that's something that differentiates latent class cluster analysis from other types of clustering techniques. In addition, it's non-parametric in the sense that you don't need to look into the normality of the data or anything like that. Um, so I think that's more or less everything about latent class cluster analysis in Jamovi. I hope you find this video useful. If you liked it, please give it a like. Have a good day and stay tuned in for more videos about Jamovi and other software packages. Goodbye.